we're on the area of a triangle. The area of any triangle, area of any triangle is always half times base times height, where base is always perpendicular to the height. So this is a triangle now. Let's label A, B, C. The height so this is the base and this is the height. So AD is the height, YBC is the base. Or, as you can see, if it's not directly perpendicular, but if you extend the base, and you notice if it's not directly perpendicular, and you notice that if you draw this is the base now, that if you extend the line, this is the height, and they make an angle 90. So I'm saying that this is also the height. So this is also half base times height. Area of a right triangle. Area of any right triangle is always half times the leg. That's leg 1 times leg 2. We know legs, this is a right angle triangle. The leg is always the sides that are the sides apart from the hypotenuse. You know this is a right triangle. If it is A, B, and C, this is the hypotenuse. So the other sides that is not the hypotenuse that are called the legs. So this is leg 1, leg 2. So since they are perpendicular, area of any right angle triangles are always half times leg 1 times leg 2. Area of an equilateral triangle. This, if you have a triangle A, B, and C, is equilateral if all the sides are equal, they are congruent. So I'm saying that if here is A, here is also A, here is also A. So our area of any equilateral triangle, assuming the height, let's call this H. We know that since the sides are equal, each of the interior angles is 60 degrees. So this is 60. This is also 60. And you know the height is always a perpendicular bisector. So this is 30. So meaning that from here, this is, okay, if I call here D, here is now half A. This is also half A. So from here, the area, we know that area of any triangle is always half times base times height. And we know that the base is A. This is the base, is always perpendicular to the height. And our height is H. But we can still write, H in terms of A. Remember from our 30, 60, 90 triangle theorem. So if here is A, half A, H will be A over 2 root 3. From what we call 30, 60 triangle theorem, or use Pythagorean theorem, our height is half A root 3. So what we have now is that area of any equilateral triangle is now root 3 over 4A squared, where A is the side. So that's it. So this is the first formula for equilateral triangle. We can still find the area in terms of the height. The height. So from here, we can replace A in terms of height. So it's possible we might be given the height and you're asked to find the area of an equilateral triangle. So we can do it. So we can still write the area. Remember, this is now area in terms of side. So this is the first formula for that. Also, since we know that height is a over half a times root 3, so making a the subject of formula, we see that, which implies that a is now 2h over root 3. Therefore, a squared is now 4h squared over 3. So we can replace a squared as what? 4h squared over 3. So the area again, the area of any equilateral triangle, we can write it as root 3 over 4 times 4h squared over 3. Because our a is 4h squared over 3. So what we have now is now root 3 over 3h squared. So this is another important formula. So we can find the area of an equilateral triangle in terms of the sides or in terms of the height. So that the two formulas are very important. Area of SAS triangle. SAS, side, angle, side. So we are given two sides and an angle. So assuming this is triangle A, B, and C. We are given, okay, let's call here small letter A, small letter B. Two sides, because we are given side, angle, side. So assuming we are given these two sides and an included angle. That's why the angle is between the two sides, which is angle C. So let's get the area of this, given two sides and one angle. We know that area of any triangle is always half base times height. So that's the first thing we know. Okay, but we are not given the height. Assuming we introduce this height as h, though it could be, it's not the perpendicular bisector, so just height h. So let's now write h in terms of the angle and this side. This is the hypotenuse, because this is a right angle triangle. This is the hypotenuse as B and our angle as C. But we know that sine, because what relates the hypotenuse and the opposite is sine. So we know that sine C is opposite over hypotenuse, which implies that the height now h is B sine C. Therefore, the area we are looking for is half base. Our base is A. Remember, height and base are always perpendicular. A times height. Height is B sine C. So what do you notice here now? If you are given the two sides and an included angle, the area is always half AB sine C. AB sine C. This angle is called the included angle. So it's between the two sides. So the area could be, if you check this, so we can still write it as half AC sine B. So what do you notice? ABC, ACB. Or we can still write it as half BC sine A. So these are anyone. Once you are given an included angle and the two sides. So that's the area of SAS triangle.